So carboxylic acids, just know a very few important carboxylic acid names, their structures. Okay, so if you see the common name for this HCOOH, that means there is only single carbon is there. So it is called as the formic acid. And if you see CH3COH, there are two carbons are there. We call it as the acetic acid. The common name for this is oxalic acid. This is the malanoic acid. If there is a one single methyl group between the two carboxylic acid groups, so we call it as the malanoic acid. And this one, it is a succinic acid. This one is glutaric acid. So it's a adipic acid. And finally, this one will be the pimelic acid. And you can see here the benzene with COOH, it's a benzoic acid. And the benzene with the 2-COOH, it's a phthalic acid. Okay, so let's discuss more about this carboxylic acid. So see here, so the carbon which is having the C double bond O, okay, in the carboxylic acid and its derivatives is sp2 hybridized. Okay, so if you see here, there is a C double bond O, and here if we have any double bonds, we always know the bond, the hybridization will be sp2. So that means this structure has formed by three sp2 orbitals. And if you see here, now the three atoms attached to the carbonyl compound in the same plane. For suppose this is one way attached, this is another way, and this is another way. So these are all the sp2 orbitals. And if you see here, they are all having the 120 degrees between them. So they are all maintaining the equal bond angles. Just know these things. So yeah, next see here. So the carboxylic carbonyl carbon is less electrophilic. So what is this carbonyl group? So the carbonyl group is nothing but the carbon, oxygen, which are combined by the double bonds, right? So this is, we call it as carbonyl compound. Now here the oxygen, it contains a partially negative charge. Why? Whatever the electrons that are involved in this bonding, the oxygen is trying to pull towards it. As the electrons move towards the oxygen, so the oxygen gets partially negative charge. As the carbon, the electrons moved away from the carbon. Now this carbon is slightly positive. Is this clear?
Yes.
Yes,
This
sir.
is how you will be seeing in the aldehydes and ketones. Okay, but coming to the carboxylic acid, there is some other group that is present on this carbon. Apart from the R group, there is another group that is present here. That is hydroxyl group, OH. So because of having this OH group, now whatever this partially positive charge is there, it will decrease. So that's how the electrophilic nature of this carbon decreases. What is meaning of electrophilic? The atom which is positive, that attracts the negative electrons. So carbon being the positive, it will attract the electrons. So that electrophilic nature of this carbon has decreased. Is that clear?
Yes.
Yes, sir.
Okay. Yeah. Banu, what about you? Is this clear for you?
Yes, sir.
Okay, perfect. So just know this thing. Okay. So see here, why it was caused? That's caused because of a positive resonance. So what happens here? So there is a double bond with this oxygen. Now these electrons will be moved here. So the oxygen will get negative. Now the carbon is, at the time, the carbon will be having only 3 bonds. So what happens now? The carbon will try to make a double bond here. Okay. How it will make? Whatever the hydrogen is there, that hydrogen will leave off like H plus, and whatever the minus will be created, this minus will move here and it will make the double bond. Understood? So see here, that's how it happened. So there is a resonance was happening. So that resonance, we call it as the positive resonance, which is induced by the hydroxyl group that is present here. Understood? So because of that reason, the electrophilic nature of the carbon in the carboxylic acids of the carbonyl compound decreases compared to aldehydes and ketones. Understood?
Yes, sir.
Okay.
Yes, sir.
So now see here,
Yes,
acetate
sir.
ion. Acetate ion. So tell me what will be the answer? So what is acetate ion? It is something that is formed from the acetic acid. Acetic acid, what is that? It is CH3 COOH, and it has converted into acetate ion. That means here whatever the hydrogen is there, it will break the bond and it will turn out to be CH3 COO minus H plus. So tell me, what is the option? Come on, quick. Come on, guys. Answer it. What is the answer?
Sir, option C.
Okay, Nitya says option C. What about you, Banu? What is your option?
The option C, sir.
Okay, Banu also says option B. What about Shrikar, Mandara?
Sir, option C varies.
Option C, sir.
You all are sheeps. What one has selected, the all others will just follow that. See, look here. This is the acetic acid. CH3 C double bond OH. And if it become the acetate ion, CH3 C double bond O. Now see here, there is a C O bond is present and there is a C double bond O is present. So what is the option?
Option A.
Hmm. Come on, guys, please think. What others says, don't just follow that. Okay, so these are the different ways of preparations of carboxylic acid. So we'll be seeing up to here today. Okay, so we'll be seeing from the primary alcohols and aldehydes, from the alkyl benzenes, from nitriles and amides, and from Grignard reagents. In the next class, we'll be seeing the acyl halides, anhydrides, and the esters. I thought I could teach these two today, but then it will take another 1 hour. So we'll go up to here. Okay. So let's see from the primary alcohols. The first one, primary alcohols and aldehydes. In that, let's see the primary alcohols. So primary alcohols means what? First of all, what is this primary means? See,
Carbon attached to
yeah. So the functional group is attached to the carbon. That carbon is attached to only the other single carbon. Then we call it as, it is only attached to one alkyl group or one R group. So we call it as primary. If it is attached to two different R groups, we call it as the secondary. If it is attached to three different R groups, we call it as the tertiary. Understood? So here we are discussing about the primary alcohols. So what's now? So see here, all these primary alcohols and the primary aldehydes, they will oxidize to prepare the carboxylic acid. Why? If you see here, alcohol is having only one oxygen. But if you see here, the carboxylic acids is having two oxygens. That means you are adding the oxygen. So you can say this is a oxidation reaction. So always remember, the alcohols or the aldehydes or the ketones, all these will oxidize and give the carboxylic acids, not the other way. The carboxylic acid will reduce and make the alcohols, aldehydes, and ketones. Understood? So remember,
Yes.
so whatever the reactions that we are doing here, all the three methods, they are all oxidative reactions. They are oxidizing here. Just know this. So this is oxidation reaction, this is oxidation reaction, this is oxidation reaction. But what is the difference is the things that we use here is a different. The reactants that we are using here is different. Understood? So first one, let's see, this is one type, this is the second type, and this is the third type. Understood? So see here, the first one. So what's happening here? It's a primary alcohol. Okay, all these are primary alcohols. Remember. Okay, but whatever the thing that you are using here, it's different. So here, the primary alcohols, they are oxidized to carboxylic acid by using the potassium permanganate. Remember. So what is that? We are using the solvent. It is a potassium permanganate. And which condition are we using this potassium permanganate? In the alkaline condition. Remember this. This is very, very important. It's not an acidic condition. It's an alkaline condition. So that you will do, you will be getting some intermediate. Then you will be followed with the acidification. Okay. You will be followed with acidification where it is S3O plus. Understood? So in the first method, how we are preparing the alcohols? We are going with the potassium permanganate in alkaline condition and followed by the acidification. So you will be getting the carboxylic acid. I'm not digging into the mechanism, just the substituents, I mean the reactants and the products. Is this clear?
Yes, sir. Yes, sir.
Yes, sir.
I think Mandara and Nitya didn't understand.
Understood, sir.
Then why? Say yes.
Yes, sir.
Okay. So see here.
Sure.
Okay. So see here, in the second method, we are using the potassium chromate. So what is this? This is a potassium chromate. And which condition are we using here? In the acidic condition. In acidic condition. Here you remember, we use the here we use the alkaline condition. Whereas here we are using the acidic condition. So that will convert into the carboxylic acids. Okay. So the primary alcohols has turned up into the carboxylic acids. And the third one. So in this, you are using the chromium trioxide in the aqueous sulfuric acid. Remember this. And remember, this chromium sulfate, I mean this, whatever the chromium trioxide is there in the sulfuric acid, we call it as the Jones reagent. Remember this. It's given here. So just know this. So what is this CrO3? It's nothing but the chromium trioxide. This chromium trioxide in aqueous sulfuric acid, which is also called as the Jones reagent, we will be using as the third way where you will be converting the primary alcohols into the carboxylic acids. So just remember, these are all primary alcohols, but they are converted into carboxylic acid in three different ways. One, you will be using the potassium permanganate in alkaline. Two, you will be using the potassium chromate in acidic condition. Three, you will be using the chromium trioxide in sulfuric acid. So there are two acidic conditions and one alkaline conditions. And here the chromium trioxide with the sulfuric acid, you will be called it as the Jones reagent. Understood? So see here. So acidic KMnO4, acidic K2Cr2O7 and CrO3 H2SO4. This is also acidic condition. All these will be converted into the carboxylic acids. That's about the primary alcohols. Let's see the primary aldehydes. Okay, so aldehydes. So what's happening here? So here you will be categorized into two main ways. Okay, first the mild oxidizing agent. Second one, the other oxidizing agent, or you can say it is a strong oxidizing agent. Okay, so first one is the mild oxidizing agent. Second one is the strong oxidizing agent. Okay, and remember this, you should remember this is very, very important. Tolerance reagent, wherever you see the tolerance reagent, it's always gives the silver nitrate in ammonium solution, or you can say in ammonia solution. We'll see the reaction in detail, but just know that Fahling's reagent, here the Fahling's reagent, it is the copper sulfate in alkaline solution. Okay, and here you are using the strong oxidizing agents. It could be the nitric acid, it could be the potassium permanganate, it could be the potassium dichromate. Know these names. So this is potassium dichromate. This is potassium permanganate. And this is nitric acid. So tell me how many of you are writing the notes, running notes?
Someone right.
Okay. Please don't be lazy, write. Shrikar, especially you. Ray, Unnava? Is he in the class?
Yes, sir. I'm there.
ఎరా ఎంత చెప్పు నువ్వు క్లాస్లో లేవా
No, sir. I'm there.
మరి ఏరా రెస్పాండ్ అవ్వడానికి ఎంత చెప్పు రే
Yes, sir.
క్లాస్ చెప్పినప్పుడు క్లాస్ విను వేరే పక్క పనులు చేయక
No, sir. I don't know. I didn't unmute.
Okay. So see here, for suppose let's take an example. So RCHO, you will be doing the oxidation and it will be converted into RCOOH. Or you take, okay. So this is how it will be conversion happens. So whatever the aldehydes are there, it will be oxidized into carboxylic acids. Okay. You can take any reagents here. You can use the mild oxidizing reagents or strong oxidizing agents for converting into the carboxylic acids. Okay. Okay. Let's see. So oxidation by tolerance reagent. So R C double bond OH, which is a aldehyde. So this aldehyde, can someone say what is tolerance reagent? What is tolerance reagent? 2 Ag NH3 twice. Please guys read. We have discussed many times what is this tolerance reagent. Okay, so remember this, the aldehyde reacting with the tolerance reagent, okay, and with the hydroxyl group, so that it will be giving the carboxylic acid. So it will form O minus, and that will meet up with H, and there is 2 Ag plus, and there is a ammonia, and there is a water. So here, can someone say what color will appear here? When you use tolerance reagent, what color it will appear? What is this?
Sure, sir.
Yeah, it will make silver mirror at the test tube, bottom of the test tube. Okay, so just remember the metallic silver will act like a deposit and which will cause the silver mirror at the bottom of the test tube. And you will be getting the ammonia and water. And there is a carboxylate ion. This carboxylate ion will join up with the hydrogen and it will form the carboxylic acid. Okay, so remember this. Okay, so aldehydes, they react with the tolerance reagent in the presence of hydroxyl ion, and they are giving this silver mirror and carboxylic acids and ammonia and water. Clear? So Fehling solution. So what happens in this Fehling solution? Again, so there's a RC double bond OH aldehyde with a 2Cu plus 2 plus 5OH minus. So the reaction will happen and result in formation of the carboxylic acid or the carboxylate ion Cu2O plus water molecule. Can someone say what color will it appear? Cu2O. What is this?
Citrus oxide.
Yeah, which color it will?
silicose, citrus oxide, red brown.
Precipitate. Actually, it's a copper oxide. Okay. So it will give the red brown precipitate. Remember this. Okay. And the carboxylate ion and the water molecule. So aldehydes, they will react with the copper ion and the hydroxyl ion, and it will be forming the red brown precipitate. So that's a phalanx solution. Remember this. So there will be red brown precipitate, and here it will be silver mirror, or you can say the metallic silver. Understood? Is this clear? Both the
Yes.
solution, tolerance reagent and the phalanx solution.
Yes, sir. Yes, sir.
Okay. Tell me what is the answer? So tell me, what is this reaction at least? Shrikar, you tell me. What is this?
Tolerance reagent.
Yeah, it's a tolerance reagent. Shrikar,
Yes, sir.
what color it will precipitate?
Silver mirror.
So see here. So what happens here? So you will be taking the benzene. It's not a benzene ring. Okay. So it will form the double bond O. The double bond O will not be disturbed. And whatever the aldehyde group is there, that aldehyde group will convert into the carboxylic acid group. The carboxylate ion actually. It will fuse with the proton if you do the protonation, and it will turn out to be carboxylic acid plus 2Ag plus ammonia plus water molecule. Remember this. So just simply remember, when you are using this AgNS3 twice, so what is this AgNS3 twice? What do we call it as?
Tolerance reagent.
Tolerance reagent. Okay. So it will be turned out to be the AgNS3 and the water molecule. So here this Ag, it will form the silver mirror. Okay. Just remember this. Now tell me, what is this? Come on, guys. What is the answer? At least tell me what will be the product it could be formed. Where do we saw H2CrO4?
Sir, OH will be replaced by COOH.
Yeah, what about the ketone? Remember H2CrO4, where do we saw? Do you remember the CrO3? What is the CrO3?
Some joints.
Chromium trioxide. This chromium trioxide, when it will be there with the sulfuric acid, it will form the Jones reagent. Whatever, it is a oxidizing agent. Remember this. Okay. So now tell me what happens. If you see our heading so far, we said the primary alcohols and the aldehydes converting into the carboxylic acids. Yes or no?
Yes, sir.
Yes or no? The topic heading is what? Whatever the aldehydes and alcohols are there. So we said only about the aldehydes and the alcohols. Did we say anything about this group? Tell me what is this group first of all?
Ketone.
It's a ketone group. So have I used the ketone word in this few slides? I didn't use. So just remember, ketones, they will not oxidize to carboxylic acids. Okay, just remember, ketones do not undergo oxidation. Okay, remember this. So ketones do not undergo oxidation. Only the aldehydes and the alcohols will undergo oxidation. So this group will not be disturbed. Over whatever this group is there, it will be replaced with the carboxylic acid. So it will be something like this. And whatever the double bond O is there, it will not be disturbed. The ketone group will not be disturbed. So just remember, the ketones are difficult to oxidize. Okay. So whatever these ketones are there, they will not undergo oxidation. Only whatever the primary alcohol is there, that primary alcohols will oxidize to carboxylic acid. Understood?
Yes, sir.
Yes, sir.
Okay. So see this one, next one. So from the alkyl benzenes, okay. So here the conversion of these alkyl benzenes, and they were converted into the aromatic carboxylic acids. Understood? So whatever the aliphatic is there, this aliphatic will be converted into the aromatic through the oxidization. Okay. Here what we are using. So you can be used as the KMNO4. So what is this KMNO4?
Potassium.
It's a potassium permanganate.
Mag-
Okay. So this potassium permanganate, it could be either the acidic condition or alkaline condition. Remember here. Okay. Or you can also use the chromic acid, which is H2CrO4. Remember this. Okay. This one. So actually this should come before. Anyways, H2CrO4, remember, it's also a good oxidizing agent. So it will be converted into the aromatic carboxylic acids. And remember, only the primary and secondary alkyl groups, they can be oxidized to the carboxylic acids. And when it comes to the tertiary alkyl groups, they do not react. Understood? So only the primary, secondary, they will show the carboxylic acids. Tertiary, it will not show anything. Okay? Understood?
Yes, sir.
Yes.
One second, guys. So is this clear for everyone?
Yes.
Yes, sir.
Yes,
Okay.
sir.
Yeah. So let's
Can
see.
you show the previous slide one?
Yeah. Just know this potassium permanganate, It could be in acidic or alkaline conditions. So they can be converted into this aromatic carboxylic acids. And primary, secondary alkyl groups, they will be oxidized to the carboxylic acid, but the tertiary alkyl group, if you use, it will not react.
Yes, I can.
Okay. So see here, oxidation of the side chain. First, let me give you an example. Okay, see here. So what's happening here? Oxidation of the side chain. That means oxidation that converts the alkyl side chain. Okay. So for suppose if you see here, this is the benzene group, and this is the side chain that is present. Okay. This side chain can be CS3, or you can take CH2, CH2, CS3, your wish. Okay. It could be single or it could be many groups, but you just take a alkyl side chain. Okay. So this alkyl side chain, it will be converted into the carboxyl group. So whatever this alkyl side chain is there, it is converted into the carboxylic acid. And between you have an intermediate. And here we will be using the oxidizing agents. One is the potassium, KMnO4, potassium permanganate. Okay. And you will be using the KOH, potassium hydroxide. And you will be eating this process. And you will be getting an intermediate. This is called as the potassium benzoate. Remember this. So this is a potassium benzoate, which is an intermediate. And you will be getting the final, that's a benzoic acid. Remember this. Okay. So what is this? The benzene group with CS3, what do we call?
Toluene.
Yeah, it's a toluene. So the toluene is converted into the potassium benzoate, which is an intermediate, by using the potassium permanganate and potassium hydroxide. Okay. And you need to heat it so that you will be getting the potassium benzoate, which is an intermediate. And this will, on acidification, H3O plus means on acidification, you will be getting the benzoic acid. So in this entire thing, what happened is, whatever the alkyl side chain is there, that alkyl side chain, it has converted into the carboxylic acid or the carboxyl group. So this is the carboxyl group. And this is the alkyl side chain. Is this clear?
Yes.
Yes, sir.
Yes, sir.
Okay.
Yeah.
And remember, you should notice here. So whatever the KMnO4 is there, it will break down into K plus MnO4 minus. So in this MnO4 minus, we call it as the permanganate ion. So this permanganate ion, it is a very strong oxidizing agent. Remember this. So this strong oxidizing agent is really helpful for breaking the carbon-carbon bond. So you see here, this carbon and this carbon, this will be helpful for breaking this bond. Understood? And that will form the carboxyl group. I mean, there will be so much of intermediates are there. You may think that CH3 here and CO, they are intact, but actually they break and they undergo reaction and they finally attach here. So I'll not be going into detail mechanism, but just remember this. So whatever the alkyl side chain is there, it will convert into the carboxyl group with an intermediate that's a potassium benzoate. For forming the intermediate, we'll be using KMnO4, KOH. For forming the intermediate to the benzoic acid, we will be using the acidification. So this acidification will replace the potassium ions with the proton. So that's how it will turn out to be COOH. Understood? So you can take an example here. Understood? So how does it form? So whatever the side chain is there, the alkyl side chain, it has turned out to be the carboxylate group. Understood?
Yes, sir.
Okay. So next one. So preparation of these carboxylic acids, here the terrestrial alkyl, benzene, do not undergo oxidation. We saw, okay? So it will not undergo oxidation. So remember, this one, okay? So it will not undergo. And coming to next one, unsaturated alkyl chain is also oxidized to carboxylic acid. The cleavage of C double bond C takes place to COOH. So what does that mean? So whatever the unsaturated chain is there, for suppose, let me give an example. So C6, so C6H5, CH double bond CHCH3. So here came an O4 and OH minus. And you need to supply the heat as well. So this is the first one. Second, what we did the acidification, right? S3O minus. So finally, what happened? It will form the carboxylic acid. If you remember the previous, so what do? First KMnO4 KOH heating and then S3O plus. So it got the carboxylic acid group. The same we are doing here. Okay, so what's happening here? So whatever this unsaturated side chain is there, that means this is the benzene group. Okay, you can see this is the benzene group. On this benzene group, CH is present and there is a double bond and there is a CH CH3. So this is how it is present. Now what happened? So whatever this unsaturated side chain is there, it will break the bond between these two double bonds. So remember, the bond will be broken like this. Okay, and that will result in formation of the carboxylic acid like this. So whatever the double bond is there, it will break and it will result in formation of carboxylic acid. Is this clear?
Yes.
So what happening here? It's a oxidizing, right? So this type of breaking, we call it as the oxidative cleavage. Remember this. Sometimes the question will come like it will undergo oxidative cleavage. You may not understand what is meaning of oxidative cleavage. So whatever the double bond is there, you are doing the oxidation that result in break of the double bond. So we call it as oxidative cleavage. Result in formation of carboxylic acid. Understood? So you can take examples here. So C6H5C triple bond CCS3. Understood how it got? Or if you use C double bond O. Okay, leave it. Any doubt so far?
No, sir.
No, sir.
Okay. So then give me this. What will be the answer? Send me the answer in WhatsApp. Come on, quick.
So
Yes, Nitya.
so should we send it or I got disconnected?
Yeah, send me in WhatsApp.
Okay, sir.
Okay, it's okay. Time is already 10:40. So let's see. Check your answer. It would be COOH. Or you can say okay. So this is the answer. You got the same answer.
Yes, sir.
Yes, sir.
Yes, sir.
Banu, what about you? Is she in the class?
No, sir.
Okay. So next one, from nitriles and amides. We'll do one thing. We'll stop here. This part I'll explain later, tomorrow.
Thank you, sir.